to survive, Bitcoin will have to adapt as the environment changes. So personally, I see the risk of ossification sort of being very dangerous for Bitcoin, whereas the risk of providing a paintbrush is not without risks, but it also has this enormous amount of opportunity.
Hi, Ethan. How are you?
Hi, good. Thanks for having me on.
This is super fun, isn't it?
Yeah.
Yeah. I love this. Is like now we're like officially taking Bitcoin Rails on location. You were actually the impetus for this trip. I was like, I need to interview Ethan. He doesn't travel. And so I'm going to have to, come out to your neck of the woods.
Well, I hope you're enjoying beautiful Boston.
Yeah, it's a beautiful summer that we're having. We've gotten a chance to know each other a little bit over the past few months working on with Hunter. You and Hunter, you came on to work with Hunter as co-author of BIP 360 recently. I've obviously been kind of doing my best to support Hunter in that effort, working with him at Mira. And I'm excited to chat about that. But I remember when we very first met at MIT Bitcoin Expo. Do you remember that vaguely?
Yeah.
And I was like so amazed to meet you because at that time I was like learning so much about Opcat, and Opcat was getting all this attention, and it was like kind of fascinating to get your behind the scenes kind of experience and learn a little bit about the history of Opcat. So I'd love to kind of start with that before we get into the quantum stuff.
Oh, sure.
Wait, so when did I don't know if people actually know that you're kind of like under the radar as the co-author of the Opcat BIP. In the sense that like Eric and Udi, I feel like have made this like big public parade kind of Opcat.
I mean, I should be clear. Like Eric and Udi are not co-authors on the BIP.
They are not.
No, it's me.
Who is your co-author on the BIP?
Armin. If you know him on GitHub, is Dead Beef, although I think he changed. But yeah, so I've been working with Armin on it. The original impetus of it was in 2015. I was doing a lot of work with Bitcoin privacy and building Tumblebit, which was early Bitcoin privacy protocol. And I just kept running into this fact that I'd want to do something, and I tried to figure out how to do it. And sometimes I'd succeed and sometimes I wouldn't. But even when I succeeded, it involved this enormous amount of complexity. And I was just like, if I could take two variables and combine them or add them in some way, I would be able, like, all of this would be easy. So I really wanted Opcat, and there was some talk of this at the time. There was this paper, Liar, Liar, Pants on Fire, that talked about Opcat. And so I was like, yeah, we'll probably get Opcat in a little bit, and it'll improve all of this stuff.
You were bullish. You at that time, and this was what, 2016. You said you were like, we'll definitely get Opcat, no big deal.
We'll get it eventually. We had just gotten op check lock time verify and op sequence verify. I think hadn't been there yet.
Okay. Were they integrated at the same time as like SegWit, basically?
No, well before SegWit. And so and then also like SegWit, it was like, well, maybe SegWit will happen, maybe it won't. But I just sort of figured it's like such a simple opcode, it gives you so much that we would get it sooner or later. But in all my protocol designs, I took a very conservative approach. So like Tumblebit has Lightning-like payment channels to some degree. But it's limited. It's not quite as nice as Lightning because I didn't assume SegWit. I didn't assume that we would have these witness malleability fixes. So I was just like, I really wish I had Opcat. Someone should do it. And then around 2019, 2018, I was talking to some of the core devs and I was like, Opcat would be great. Maybe I'll propose a BIP to do it. And I had a BIP on my hard drive that I'd written back then. And they were like, well, when we get TapScript and these other changes, it'll be much easier to add new opcodes because you can use opsuccess.
They said the same thing to Jeremy Rubin, I'm pretty sure. I think this was like a common narrative at the time for BIP authors.
And I think it's a very true narrative. Like the ability to add opcodes with op success makes these upgrades trivial, much easier, much safer, just all around much nicer.
Why is that? What is it about op success X that makes it so much easier to add opcodes?
So Bitcoin really wants to avoid hard forks. And they want all upgrades generally to be soft fork. It's become this sort of culture of soft forking. And the definition of a soft fork is that the change does not introduce any new functionality, but like restricts what can be spent. So like if you think of the circle of all valid transactions, a hard fork is like a new circle that adds like a bump here.
It expands capacity for Bitcoin rather than restricting it.
Right. And a soft fork only restricts it. So the awesome thing about having these op success opcodes is that if a transaction has an op success opcode, even if it like is inside of an if that isn't executed, it just automatically succeeds. So if you put those like bytes in there, boom, automatic success. And so what that means is that it's very easy to soft fork because now you have this giant circle that will always succeed. And then you can just right size it to the thing that you want.
And prior to this, like it was, I think you had mentioned like it was a little bit more, I don't know, iffy, dangerous, like introducing new opcodes was just like substantially more complex and nerve wracking for people.
Yeah. And this was because, many of the opcodes that you'd want to use that weren't currently assigned, like essentially like did nothing or caused like a failure. And so now it's this like really, really tiny circle and you're like trying to, expand it. And sometimes you can get away with it if you're really, really clever and you think about it and it matches the use case that you're doing in some, really smart way. It has to be more
perfect.
But it has to be more perfect. And if you mess that up, you might cause a hard fork. Whereas with this one, it's like the only thing you can do is shrink it because it's op success.
You can only soft fork. The hard fork risk is like basically obliterated.
Right. There's still some ways that you could mess it up.
Rare.
But you almost have to like go out of your way to do it. Versus before it was this whole project just to think about how to do it. So I feel like it made Bitcoin so much more powerful, and so much more, these opcodes.
Like easy to express. Yeah.
Yeah. Easy to add new upgrade functionality, which was very much the intent.
Which is interesting because my impression, and tell me if I'm wrong about this, is that it has politically become more difficult over time to add new opcodes to Bitcoin. So op success X, just for context for folks who are watching, was part of the Taproot upgrade.
Right.
That was introduced as part of Taproot. Since Taproot, my impression is that it's more difficult, not less difficult, politically at least, to add new opcodes to Bitcoin and make changes to Bitcoin, generally speaking. I mean, first of all, would you agree to that? And why do you think that is, given this technical advantage that we have now?
So I would agree that it has gotten, over time, it's gotten more and more difficult to change Bitcoin. Politically, but technically, a lot of work has been done in Bitcoin to actually make upgrades easier and less disruptive and nicer. So technically it is the perfect time to upgrade Bitcoin. Politically, it's much more difficult. And I think a lot of this is Bitcoin's maturity. If you go back and look at some of the really early, like Satoshi, commits, Satoshi, we didn't even know what hard forks and soft forks were. And Satoshi would just make like major changes essentially without, I don't know whether, Satoshi consulted people or not. But
probably not in like the early days. Yeah. Well, like Satoshi and his team, whoever they were, just did things, right? I mean, they just made changes.
The opcode that removed opcat is called miscellaneous changes. It removes opcat. It changes the mathematical opcodes from 5,000 bytes to 520 bytes, and removes most of the mathematical opcodes. It removes about 12 opcodes in total. Just, massive changes in a miscellaneous commit message. And I think, I think some of the difficulty now is like, it's a serious project that you can't do something like that.
Right. There's a lot of money on the line now.
Yeah. And there's a lot of like people that would, if you propose that today, you'd get like laughed out of the room. There's just, Yeah. So I see it as almost a product of Bitcoin's success and Bitcoin's sophistication as a project that people really care about.
So are you surprised that Opcat specifically has, so what's sort of like your take on how Opcat's been received over the course of time? I mean, you first proposed this in 2019. How was it received then? How have things changed? Udi and Eric, this has evolved with them. Like, what's sort of been the story of the political receival of Opcat over time?
Sure. So in 2019, I had it on my hard drive and I emailed it around to some people. I was talking to Jeremy Rubin about it, and we came up with another BIP that we ended up not publishing, but I threw on the dev mailing list. And I kind of just put it on the hard drive until we got Taproot. And then once we got Taproot, I was talking about it with some friends. And we went out to lunch and I was like, I got this Opcat thing. It would be really cool, but it's a lot of work and I don't have a lot of time. I was doing a startup at that point. So,
a Bitcoin startup?
It was originally a Bitcoin startup that became a cybersecurity startup, that got bought by Cloudflare last year.
Okay. And that's why you're at Cloudflare now, right?
Yes.
Okay. Yeah. Okay. That makes sense.
And I'm not representing Cloudflare in any way in this.
No, of course not. Yeah. No, of course.
But so Armin was like, no, I can work on it. And he had really liked this idea of non-equivocation contracts, which was one of the first proposals for Opcat way back in the day. So he did a lot of the work, and helped make the BIP much better. We worked together. We put it on the dev list and then we published it. Udi and Taproot Wizards, sent me an email and they were like, we think this is really cool. We really like this. Do you have any objection to us talking about it and supporting it?
When was it originally published on the mailing list?
I think it was originally published on the mailing list, maybe 2023.
Okay, so they came in pretty fast.
They came in pretty fast.
You'd been working on it for many years up until that point, but it wasn't actually proposed until 2023.
I think I might be wrong on the year. It might be 2024,
yeah,
but around there.
Around then. Okay. Recently.
And my take with that is anything I do with BIPs, it's no one needs my endorsement to work on it or criticize it or to support it. It's like a gift given to the community.
Yeah.
I was glad that they were interested in it, but I also felt like it would be weird for me to say to someone no, you can't support this, you can't criticize this, because it's just an open idea. Opcat itself was in Bitcoin at one point, so
were you surprised they asked you? Why do you think they asked for your permission to get so loud about it?
I think this is just pure speculation on my part. But I think that they were concerned that if they talked about it, and then I was like, "How dare you support this?" And attack them, it would backfire on them. So I think they just didn't want the headache of talking about a project and supporting it, and then having the authors come back to them.
Were you aware of them being controversial figures in this space at that time?
Yeah.
Okay.
But I think that the nature of Bitcoin, as quotable Taj, which you're having him on later, is this the money of enemies, and controversial figures sometimes have good ideas, sometimes have bad ideas, but I don't think that we should be that we should live in these sort of intellectual walled gardens where it's I don't want this person to talk about my ideas.
And we should be, assessing ideas for ideas' value, not the people who propose them. I think that's one of the biggest challenges that Bitcoin and maybe all politics faces, right? Is judging the proposer rather than the proposal.
Well, and if we judge ideas based on the proposer, you give controversial figures enormous amounts of power, because it's they can now kill ideas by simply supporting them. And, regardless of what people think of Taproot Wizards, I don't think anyone would want the ability of Taproot Wizards to have a veto button over any changes in Bitcoin.
So I could speak to specific criticisms that I'm aware of, but what do you think are valid criticisms of Opcat? What are things that people are concerned about that you think people have a fair point on, if any?
So I think that I think a lot of people have fair points on OpCat. And almost all of them come down to a difference in philosophical position. There are people that see Bitcoin as that we should identify use cases, and then we should produce opcodes that are specifically targeted to that use case that we've convinced ourselves have no off-label uses.
That's what people want. Like, that's what like certain people want. They want only things that can be used for specific things and that don't have experimental off-label use cases, as you call it.
Yeah, I think some people want that. My view is very opposed to that. It's not that they're wrong. It's like just a different philosophical view. I don't think that we can imagine what people can do with like Bitcoin, even if we think really hard, because these things build on top of each other.
Like, even if we try to constrain it, we won't succeed.
We won't succeed, but also I don't think we should try to constrain it, because someone will build like a protocol that's a little bit different than we think. And then we'll see it can actually go further, and we can see it can go further. And there's no way to like predict that set of growths. So we should provide useful, simple, general purpose tools, that are, not disruptive to Bitcoin, but that don't presuppose what people will do with them.
Wouldn't you say, and I'm just like play devil's advocate here though, like if you give people like broad paintbrushes to do things with, which is I think like the main criticism of OpCat, right? It's such a broad paintbrush. We don't know what people are going to do with it. Like the concern, what would you say to somebody that's like, yeah, but like what if something really bad happens, right? We don't know what people are going to use this for. You know, maybe it could be used for something problematic.
I mean, I think that we can't really prevent that. I would prefer the opportunity that it provides to the risks, just because, and you know, this sort of comes back to a philosophical take, is that like systems evolve and they live within a bunch of like use cases and things that people understand them as useful for and not useful for. And that if you were to say like take any organism and like freeze them and prevent it from evolving, like that's kind of like the death of that organism. And so I think that to survive, Bitcoin will have to adapt as the environment changes. So personally, I see the risk of ossification sort of being very dangerous for Bitcoin, whereas the risk of providing a paintbrush is not without risks, but it also has this enormous amount of opportunity.
So going back a little bit into why you put this proposal forward, all of these sort of examples that you told me, you were like, oh, it would be useful for this, would be useful for that. None of the ones that you mentioned were like covenants or like bridging, which I think is the primary interest for OpCat right now, right? People want to use this because they can kind of make these sort of imperfect but still functioning trust minimized bridges with it, or trustless bridges with it.
Yeah, so I think there's been a lot of interest in using OpCat for bridging or for covenants. The interesting thing about OpCat, and I see this as an advantage, some people see this as a disadvantage, is that it's really bad at covenants, and it's just enough to like be able to build bridges, but it's not ideal. It's not ideal. And so I see this as it's been said that we get, and I don't fully subscribe to this theory, but there's this theory that we get one chance at a covenant opcode. And when we produce the covenant opcode, if it turns out that we didn't fully think through all the ways in which it could be used, it will be very hard to put another covenant opcode, both because that will involve people admitting that they were like wrong and missed something. But then two, people will be like, well, this one's already good enough. And the advantage of OpCat for things like covenants, in my mind, is that it's not quite good enough. Like, it's good enough to experiment with, but it doesn't stand in the way of, after we learn a bunch of lessons with OpCat of like what people are actually using covenants for, then you can do a special purpose covenant opcode.
Well, and my impression, and correct me if I'm wrong, but my impression is like a lot of these different sort of like layer 2/scaling protocols actually need different types of covenants, right? Like different, like TX hash is like better for this one, and CTV is better for this use case or whatever. Like different covenants are more appropriate for different ways to build on Bitcoin, and Opcat, is not really perfect for any of them, but can kind of like be used to be worked around all of them, if that makes sense. Is that fair?
I think that's fair. And I think that's just the nature of the trade-off. As you start more specifically designing an opcode, you start encoding the use cases that you'll use it for. So Opcat is, jack of all trades, master of none. And then something more specific where someone has this like burning use case they really want. It's like, okay, well now you're doing trade-offs. So it's like really good at that use case, but maybe there's someone else's use case it doesn't satisfy.
Right. Yeah. Well, so how are you feeling about this politically right now? Like, how are you feeling about the likelihood of, I remember you said eventually we'll get Opcat. Do you still feel that way?
I'm very optimistic about getting Opcat. I've kind of been taking a wait and see approach.
There's no rush, really.
I don't think there's that much of a rush. And I also think that like when you try to push something too hard, Bitcoiners are very contrarian. And so they just start pushing back out of instinct. I think also, there was a lot of talk about activating CTV or other opcodes
recently.
Yeah. And I didn't really want to like stand in their way and then have this like, which one do you do? So I wanted to see if they would, put together an activation client and then go down that road.
I don't know if you know this. There's a theory out there that Udi's support of Opcat was actually like a giant psyop to get CTV more attention and ultimately get CTV passed. Udi denies it. I had him on the show and he denied it on the show. But there's a theory that this is the case.
So from my perspective, I was really excited about CTV. And I expected it to activate. And at the time I was running,
back then, early on, you expected it to activate.
And I was, the startup that I was, a CTO of that I co-founded, Arwen, would have really benefited from CTV. So I was really excited to see it happen. And when it didn't, I was really disappointed. And that was one reason I went back to Opcat, because I felt like, CTV is, a little bit of a harder ask.
Why?
Because it's more complex in terms of code. It's focused on like Opcat is just incredibly simple. It's like you have these two variables and we just concatenate them. You like delete the
space.
Comma.
The comma. Yeah.
So, from a change to the code base, it's just like so incredibly, like people said it was like 14 lines of code. It's not actually 14 lines of code. And there's a bunch of test code that's written and there's some other code, but it's probably like one of the simplest things you could add to Bitcoin in terms of a new opcode.
But it has bigger implications. It has bigger, it has a bigger impact, arguably, right?
Yeah.
So
yeah.
I don't know if that's meaningful. I don't know.
So at the time, I did not fully understand the implications of Opcat.
Okay.
I thought it would be useful for like Merkle trees and equivocation, non-equivocation contracts and a bunch of things that I wanted to build. But the ability to leverage it into these highly inefficient, but really like universal, computations was not something that I was aware of when I first proposed it. So I saw it as, I was very disappointed that CTV didn't get in. And I was like, well, what's the thing that can like bring everyone together that is so trivial and so nice that, and so useful that, we can kind of get this started again. And then, Opcat, something I really wanted to use, but also CTV, something I really wanted to use. So it's like, oh, okay, we can take like a stepping stone. And then if we get Opcat, then we can like think about CTV. But I was really worried that the whole machine would just like jam up and then nothing would happen. So it's like, what's the easiest, smallest thing that we could add to Bitcoin?
Did it occur to you though that like breadth of usefulness might actually be the criticism, right? That like being too useful, right? Being too expressive would be the problem?
It occurred to me that people would, not like that, but there's this sort of interesting dichotomy in Bitcoin, which is when something is very specific, people complain that it's too specific. And when something is more universal, they complain it's more universal. So you pretty much just have to take the criticism. And the worst thing that you can do is try to split the difference, because then both sides will be angry. And often the criticisms, they're not necessarily being like leveraged by like factions. It's like sort of the same people, but they just want to like kick the tires and be like, well, is this too specific? Is this too general?
Yeah,
so,
they want to battle test the idea.
Exactly.
Yeah.
I don't think it's necessarily like a bad thing. But I like, I think Opcat is probably, in my estimation, fairly uncontroversial and one of the most uncontroversial, opcodes.
Still to this day.
If you look at there's like this covenants, thing on the Bitcoin wiki that shows like, support and oppose. And like Opcat is almost has very few no's, and has lots of support.
Does CGV have more no's? How does it compare to CGV in terms of?
I haven't actually checked. At one point it had fewer no's, but I think some of them have swapped.
Okay.
So for the people listening at home, they can go and play the home game and see where it is.
Go vote. On the revote, yeah.
Yeah. But I think that it is not that Opcat is necessarily highly controversial. It is that any change is highly controversial. And Opcat has a decent chance of being a change. So people spent a lot of time testing the idea.
And you would call yourself, like, this is a concern for you, ossification generally, right? Like this idea that Bitcoin's getting harder to change. Obviously, you mentioned this is, a sign of its success in some ways, but I mean, do you see that as problematic?
I think it's problematic if it's ossification for ossification's sake. Like, obviously, Bitcoin shouldn't just be doing random changes that have very little value. But there will be cryptographic breaks that Bitcoin will have to adjust to. If we look at the past, we've seen, several hash functions, several signing algorithms either get weaker or be broken. It's only a matter of time. But this is just the nature of a cryptocurrency. And maybe it's not a matter of time for the next 30 years, but for the next 100 years, what's the chance that we have some sort of cryptographic breakthrough, somewhere in something that Bitcoin depends on? There's been some, interesting attacks that were discovered in the Merkle tree, of Bitcoin, which, I believe the consensus cleanup is trying to fix. And maybe there'll be other things that are discovered. So I do think that in some sense, we need the capability to change Bitcoin, because at some point we will have to, and the ability to do that with the lowest risk and disruption. And the ability to demonstrate that Bitcoin has that capability, I think is useful for ensuring that Bitcoin lives its best life, and also useful for convincing people that Bitcoin takes these problems seriously and has the capacity to solve them, which I think it does. I'm very optimistic on it. But yeah,
you believe in Bitcoin governance. You're like, this is going to work out. It's going to be okay. The governance process sort of works.
I think so. I think we're also still discovering what the governance process works when it is fully decentralized. And one thing that I'm very excited about with BIP 360 and also Opcat is it gives us a chance to figure out how that governance process should actually function.
Yeah, you've definitely gotten an inside view relative to other folks on this governance process with now 2 BIPs on the table. You mentioned, this is a great segue, I think, into the quantum conversation in BIP 360. You mentioned this idea that, all cryptographic primitives kind of by definition are weakening against time, basically. Is that sort of your general take on quantum? Why did you agree to join Hunter in authoring BIP 360 when he asked to bring you on, I think in May?
It was a Bitcoin Expo. So whenever that
Bitcoin
was.
Expo when we met, that's right.
So I've been looking at some of the quantum problems with Bitcoin and just cryptography in general, I was hoping that someone else would do a lot of the work. And so I was
for
really,
quantum specifically,
or for
Hunter
quantum
said the same thing. Hunter said the same thing. He's like, why is no one working on this?
Yeah. And I think that, when I saw Hunter, post BIP 360, I was like, oh, like, thank God someone's like working on it. And then, just talking to him, it was like, okay, well, like, I want this to be a success, not just because, this is a threat which Bitcoin should take actions to mitigate, but also because there's a lot of people that are looking at this, and we see across the board, governments and like banks and internet standards and the internet itself is taking quantum computer attacks on cryptography very seriously. And Bitcoin should also, like, it would be bad if there was a perception that Bitcoin was not taking this seriously. And I do think Bitcoin is taking this seriously. But I wanted to ensure, and I think Hunter has similar motivation, that, it doesn't look like Bitcoin doesn't take these sorts of threats seriously.
Would you say it's fair? Would you say it's like a fair statement to say that like the optics of this are almost just as important as like actually providing protection against quantum computers? Like, are you concerned about the FUD maybe leading to lesser adoption or like hurting Bitcoin in some way?
So I think the optics of it are a little bit important. But I think Bitcoin can survive bad optics. I think that, like, I don't feel it is necessary to win the debate. I don't know what will happen in the future. Maybe quantum computers will turn out to just hit some wall and they won't be able to break cryptography that Bitcoin uses. But probably we will get, if we do live in the universe where they do break it, we'll probably get like a series of warnings. So I'm less concerned with like convincing people in the Bitcoin community that quantum computers will break Bitcoin, because by the time we need to make these changes, probably, it will be like kind of like self-evident to everyone. But where I think the optics do matter is the actions people take as it becomes self-evident that some action should be taken. So like if we have a well thought out plan with this is how we do it, then when it's like, oh no, quantum computers are like real and we've got to do something about it the next 3 years.
We can
point to this, and we won't have to have the fight about how we design it at the point at which it looks like we didn't put any work in.
But it's better to have like the 5-year community argument, like before we need some sort of solution to this
exactly.
problem.
Well, yeah, really well said.
All right, guys, I want to take a quick break to thank you for watching and remind you to click the follow button on my profile if you want more Bitcoin technical deep dives like this. I also want to give a shout out to my partners for making the show possible. My leading partner, Best in Slot, just released the programmability module for BRC20, making the execution of smart contracts possible for the protocol. I know that's been long awaited by the BRC20 community. Alongside this release, Best in Slot put out what is arguably the most sophisticated DEX for trading Bitcoin native assets called Coin Cooker, which I also highly recommend checking out if you want to dive into the BRC20 trading game and get started executing smart contracts on Bitcoin. I'd also like to thank Cetrea, building one of the leading implementations of a BitVN-style bridge for Bitcoin. Cetrea is building what I think could become the canonical Bitcoin rollup, enabling programmability, scaling. Really anything is possible with a trust minimized bridge, which is the unique value prop of these BitVM-style rollups on Bitcoin. Lastly, I'm thrilled to announce my newest partner, Spark, which is the leading state chains protocol on Bitcoin. State chains builds upon what was made possible by the Lightning Network for payments, but without the liquidity constraints and the UX challenges that often make self-custodial Lightning impractical. Spark is also led by one of the leading payments infrastructure teams on the planet, including founders from PayPal, Facebook. They're incredibly well positioned to turn Bitcoin into a true institutional standard for payment systems around the world, and I couldn't be more excited to support what they're up to. All right, on that note, let's get back to the show.
Okay, interesting. Do you have a take or a point of view about sort of like the timing on quantum computers, just from like you are a cryptographer, right? I'm curious to get also just a little bit of your cryptography background and how you got into Bitcoin, if that's not too off the, just for context yeah.
So I should be clear. I am not a quantum cryptographer.
Right.
And these sorts of timelines are really hard to predict. But the government is trying to get a bunch of cryptography by 2030, post quantum.
Which we don't know why they implemented that timeline exactly. Do you have does anyone have like a theory as to why the United States government wants to, sunset ECDSA in the next 10 years?
So I have a theory. Well,
you have a theory. We don't know.
We don't know. I think that 2030 was chosen as a number because it's kind of like a round number.
Okay.
Like imagine that like they did the math and it was like 29 or 20.
Well, hopefully it would be like 2031. Yeah, exactly.
Yeah. And you go for the round number.
Right.
But I think that also they're just.
But they didn't choose
2050.
Yeah. Okay.
Right.
Yeah. You just think it's just abundance of caution.
I think it's somewhat caution. I think it's also that.
You don't think it's like military industrial complex where they're like just like trying to like figure out how to like get more funding to some of these insane quantum companies?
I mean, I do think that there is like obviously the threat of quantum computers is a business opportunity for a lot of businesses. So I wouldn't discount that from the perspective of a business. Businesses may wish to promote the threat more to sell products, but generally, like the U.S. government hasn't operated that way in terms of its like cryptography recommendations. They didn't run like the SHA-3 contest because they figured it would make a bunch of people money.
Okay. So there's no like strong precedent for the government like deciding which cryptography to use based on like, industrial interests.
Yeah, I think within the United States, no.
Okay.
There may be some other. So
we can maybe put that theory to rest.
Yeah, I think the United States, I think NIST and the NSA did not make these choices for business interest reasons.
Okay.
But businesses almost definitely promote things based on,
and NIST knows what they're doing. They would know if some like salesmen were like bullshitting them about the threat of quantum computing being like more real than it is.
Yeah, I mean, NIST is extremely competent in these areas.
Okay. So we don't have to worry about that. So you think that so the United States government, this is just abundance of caution, but like they think that this is coming at some point, probably.
Yeah. And I think that.
And you think that that's like broadly like the cryptography world's point of view is that like this is coming. It's just a matter of time.
I think there's a little bit more, skepticism in the cryptography world.
Okay.
If you think about it, like, the, U.S. intelligence community, imagine it's like a 70% risk. Well, they're going to want to handle that 70% risk. But like, if you're an academic cryptographer, if you're like wrong about it and you go the 30% route, the costs are much lower. So I think that it isn't that the government is 100% sure it's a risk, but the risk is high enough that they feel the need to mitigate the risk, especially given the long timelines. And this is especially true with the threat of storage attacks, which Bitcoin doesn't really have, where like a enemy nation records a bunch of internet traffic they can't break, and then like 40 years down the line gets quantum computer and then breaks it and discovers some sort of secret. And we have seen things like this be important to national security. So like the Verona intercepts, where how the United States discovered how the atomic secrets were being stolen, but it was because they recorded an enormous amount of Soviet traffic and then like broke it like, I think a decade or two later, because the Soviet Union made some cryptographic mistake and reused some one-time pads. So I think for them, it's like even there is the risk of store and break later attacks. So even if it is not within the next 4 years, the communication within the next 4 years, they don't want to be broken in like 30 years. Okay,
that makes sense. So heading back to BIP 360 really quickly, you made some pretty substantive changes to BIP 360. BIP 360 originally included, introduction of like multiple PQ signatures into Bitcoin. There were various it was a much more like elaborate proposal initially. Can you just kind of TLDR a little bit of the changes that you suggested and why you made them?
Sure. So, the main thing I was trying to do is, keep the standard as like simple as possible and sort of follow the things which had already existed. When making like a change to Bitcoin, one of my primary concerns is that I don't want people that build on Bitcoin or writing Bitcoin scripts or smart contracts to have to like remember arbitrary rules. Every single arbitrary rule you have a developer remember is bad. Because if they forget that rule, something bad can happen. So I tried to, as much as possible, keep the changes so that there wasn't like, oh, well, if you're in the post-quantum script world, you have to care about this. But if you're in the regular Taproot world, that opcode does something different. And just, unify it into, what already exists. So specifically, the original version of the BIP, didn't use TapScript. It was just, signature verification. And one of my concerns there was like, well, okay, if we need to move to this, there is all of this work that's been done on Lightning and all these other protocols, and then like all of a sudden they won't be able to use that anymore. And the way in which signature verification would be done is slightly different. So like, how do like hardware wallets think about that?
Well, this was kind of, I remember like when Hunter was sort of like initially batting the original BIP around, it was sort of like this, what do we do about Taproot? Kind of was like one of the core questions.
Right.
And I mean, so were you the one who actually suggested removing the key path spend, which is the quantum vulnerable kind of piece of Taproot, or was that already in play?
So I don't know who originally suggested it. But if you go to the opcat BIP,
okay,
bring it all the way back to opcat.
Okay.
If you go to the opcat BIP, there's a section that's like, you can do very rudimentary post-quantum signatures with opcat.
Okay.
And opcat would only be added to TapScript. So you'd only be able to use it in, Taproot or,
How do you do rudimentary? I didn't know this. How do you do rudimentary post-quantum signatures with opcat? Are you like concatenating Schnorr signatures or something?
No. So one of the simplest signature schemes in the world, is called Lamport signatures.
Okay. Yes. I've heard of this. Yes.
Yeah.
Okay. Yes.
And it's just you hash, you want to sign 0 or 1.
Okay.
And so you, hash a secret value that's your secret value for signing, 0. And you, put the output of that hash, as your pub key for 0. And then you hash the secret value for signing 1. And that's the value, that's the pub key for 1. And then when you want to release, whether you signed 1 or 0, you release the secret value for 0.
This was the unlock for BitVM.
Yes.
Yeah. Robin Linus is very into the Lamport signatures.
So you can build Lamport signatures in Bitcoin, right now, but the really big problem is that you can't actually attach them to the spending signature. So you can sign arbitrary data, but you can't prove that it's the spending signature.
But if you can concatenate them.
Yes. You can use this Schnorr trick to get the hash of the spending signature.
Okay.
And thereby, do Lamport signatures on that.
And Lamport signatures are hash based, so they're quantum secure, basically.
So they're quantum secure. They have a bunch of other properties that, that BitVM uses that you generally don't want to use. Like if you sign 2 different messages, you probably like end up leaking your key.
Why is there not a proposal for this? Like, I'm shocked that there's not some sort of like Lamport based post quantum something or other to like, I guess you don't need to propose this. This is just something you could do today. You could just execute these kinds of kind of roundabout post quantum signatures if you wanted to.
Yeah, if you had covenants or something like opcat.
Right.
So
I guess you need opcat. Yeah. Okay. Got it.
So the opcat.
Is this an argument for opcat?
So it's in the section of motivation for opcat. It's like, you can do this, but, you need to disable the key spend path in, in Taproot.
Okay, so this is in Opcat. This is literally in the BIP. You have this in the BIP.
Yeah.
Like you can do post-quantum, like kind of like roundabout post-quantum signatures with this.
But Lamport signatures are very, like, they function very differently from a security perspective to users.
Okay.
Like right now with Schnorr signatures, you can sign like a million different messages and your key is still safe. And Lamport signatures, it's like you sign more than one message under that pub key, your key leaks out.
Oh no.
So you like really, if we were ever just to use Lamport signatures by themselves as a signature algorithm, we would have to like build a lot of like rails and things to protect people and like, have you used this pub key before? And it becomes a difficult UX problem to.
The user error like probability increases substantially when you're using Lamport signatures, like generally.
Right.
Not for novices. You don't want like regular retail users.
Yeah, or you'd have to like wrap them in some clever way.
Right. Okay.
So Suffice is actually somewhat similar to Lamport signatures, but it's built this whole structure so that you can reuse the public key many, many, many times without leaking it.
Got it. Okay. So that's why Hunter, I mean, that's sort of why the general consensus is to use Suffice for the next phase of BIP 360, whatever that BIP will be, that will introduce kind of more traditional post-quantum signatures at some point.
Yeah. Like Suffice is almost like, what if we got Lamport signatures and then a bunch of other work so you could like sign a message more than once without leaking your secret key. Okay,
so let's back up because this is like important context for people to understand. So Hunter and I did this like elaborate interview where we talked about the original BIP 360. Yeah. Now BIP 360 will only be basically this like very minor change, which essentially disables the key path spend, which is the quantum vulnerable piece of Taproot addresses, of Taproot output types. And then you guys are working on actually introducing post-quantum schemes that will be proposed as a separate BIP.
That's right.
Okay. And the general reason for this basically was just like you want to have like the simple Taproot change. You want to kind of separate these changes into like step-by-step pieces and see kind of let the community kind of argue them one by one.
Right.
Okay.
Specifically like, if we want to use TapScript in a quantum safe manner, there's two approaches. Approach one is to disable key path spends on Taproot, and approach two is to introduce a new output type that disables.
Oh, I'm sorry. I'm sorry to interrupt. I want to just make sure I understand this. This was a question that I had. Can you disable? So you have to use a key path spend right now with Taproot. You can't like just spend to a script only.
So you can spend to a script only by choosing a pub key for the key path spend, which it's provable that like you don't know the signing key of. And this is called like a nums point or nothing up my sleeve point.
Okay.
So like you could imagine
it's basically like a fake pub key.
Yeah, like if you chose the pub key that was like the first so on digits.
You could have like an alias pub key in the key path spend right now if you wanted to.
Right.
Okay.
So we just all agree that, you know, the pub key of all ones, it's very unlikely anyone actually generated that. It's cryptographically unlikely that they generated that. So no one knows what the signing key is.
Why not just do that then?
So this is actually in the Taproot BIP and it works really, really well, except, just because you and I don't know what the signing key is. There is a signing key that exists, and a quantum computer could find that signing key. So I've convinced you that I don't know what it is, but a quantum computer enters the room, and it's like, the quantum computer figures out what the signing key is, and then you can spend it.
Okay, so it's not as secure as the BIP 360 proposal that's putting forth, which literally just disables key path spend entirely, and you're just only spending to scripts.
Right.
Okay. How's the second? So now we're like talking about like, okay, there's going to be this other proposal that introduces post-quantum signatures. You guys are sort of in the research phase there. How's that going?
I think that's going pretty well. The basic idea is that just to keep things with the way Bitcoin currently works, we would do these as like op success opcodes. So we would create like right now we have like opcheck sig, and this would be like opcheck sig. Suffice.
Yeah.
Or, opcheck sig, dilithium.
Right.
and we would just add these as additional opcodes.
Oh, so you can add, you're thinking, because I remember this was like another thing that came up in Hunter's original proposal. I think there was like 2 or 3 post-quantum signatures that were introduced, basically. This would be more like each PQ signature you would introduce separately as separate opcodes.
So we might activate them together or not. Like, I think that's really like up to the community and how people feel about it.
Okay.
The idea of having more than one of these, is, there's a lot of like pushback, to have more than one signature, and understand that pushback. Wallets have to support it. There's a lot of work to be done to support more than one additional signature scheme. So it's designed to be like completely modular. So you could just add dilithium, or you could just add Sphinx, or you could add both of them together and activate them, or you could activate Sphinx first as the ultimate backup, and then as we get closer to a quantum computer, activate dilithium. But the idea is to...
And dilithium and Sphinx are currently kind of like the 2 that are being most debated. Dilithium is lattice-based and Sphinx is hash-based, right?
Right.
Okay. And so, like, do you want to share a little bit maybe about the trade-offs of those 2 things?
Sure. And so it's really... currently, we are looking at dilithium and Sphinx, but also there's a lot of interest in Falcon.
Which is also
lattice-based. So we went with dilithium and Sphinx and didn't include Falcon, although we may rethink that at a future point, because it looks like dilithium has the most amount of like support outside of Bitcoin and seems to be the direction the cryptography community is moving in for lattice-based. And we wanted to get a diversity of designs. So Sphinx and so Falcon and dilithium are very similar. They're not entirely similar. There are attacks that could break one, but not break the other one. But then there are attacks that could conceivably break both of them. Whereas like dilithium and Sphinx are like completely different things.
Right. Yeah. Because it's hash versus lattice-based, basically.
Yeah. So Sphinx is hash-based, and like hash-based signatures actually predate RSA and everything else. They were like the first signatures we really discovered.
It's like the toughest as nails signature that you could possibly have.
Exactly.
But it's large. That's the
very
issue.
large. Yeah.
Right. You don't want to be like, wielding those heavy signatures, all the time if you don't have to.
Exactly. So like the idea with Sphinx is that we have this signature scheme that we're like really sure of. If you made me like bet that I was going to send like 100 Bitcoins to the future, and, just bury the Bitcoins in like a coffee can, like seed and bury it in a yard somewhere. And I could choose what signature algorithm I would use. I would use Sphinx. It's the
bulletproof,
most likely to be bulletproof. Nothing's 100%. We don't know, but
all cryptography eventually weakens over time.
Yeah. But that's where I would place that bet. But it's, costly to sign. It's a little bit less costly to verify than it is to sign. And because the signatures are so large, the actual cost to verify per byte is actually cheaper than Schnorr. But that's because it's like, Schnorr is like 64 bytes and this is like,
a ton.
I think like 20 kilobytes.
Okay.
So it's like so much larger that's actually cheaper per byte. And then
but not cheaper per transaction, meaningfully.
Right. You're gonna be paying much more fees in transactions if you spend it with Sphinx.
Right.
And then the lattice-based schemes like dilithium are like in the middle, where it's like maybe like 1,000 bytes. So significantly cheaper than Sphinx, but still more space than Schnorr.
How have the responses been so far? First of all, to just BIP 360, remove key path spend from Taproot addresses. How have the responses been to that? And then also, how are responses kind of to the PQ signatures these days?
So with BIP 360 and just like, let's have an output type that doesn't have the key path spend, but allows us to do tap script. There's been, I would say, a little bit like unexpected. Some people, really don't want to think about key path spends. So they are like,
what do you mean they don't want to think about key path spends?
So when like dealing with like, Taproot, there's, additional complexity because you have to like be like, okay, well, I have to check that this is a nums point. So the person didn't actually just like sneak the ability to spend this output. Even though I've checked all the scripts, since there's this other way, I have to care about that. And then in terms of like designing the wallet, because it has this neat compression thing where the public key also is like a commitment to the script. You have to write a bunch of code about that. And then building like protocols on top of that. There's just like a lot of additional, like thinking and complexity, not a lot of complexity, but there's like additional complexity. And so the idea of just having an output that just only commits to, TapScript.
Right.
It's just like some people are like, oh, that's wonderful. That's what I want. Right. I only want to deal with scripts.
What you're saying is avoiding the key path spend right now is complicated. If there was just an output type where that was just disabled, then it would be easier to use without the key path spend if you didn't want to use it.
Right. And then on the other hand, there is this privacy benefit of the key path spend, which is that the key path spend, if you have it, is cheaper to spend on chain because you don't have to reveal the script. And also because you don't have to reveal the script, your spend looks the same as like everyone else's spends that are just doing regular key spends.
Right. There's no way to hide that you're spending to a script with BIP360, basically.
Exactly.
Because there's no other way you have to spend to a script. There's no other option.
Exactly. But you can have a script that's just like verify pub key checks
right, and it's not like you're revealing the contents of like what the conditions of the script are, right? I mean, it's just like, okay, they're spending to a script, fine. Like, right. You don't get more information than that.
Yeah, you can.
It's a minor privacy benefit.
You can hide you can hide the other scripts, but there will probably be people that use BIP360 to just be a pub key, and then you'll be able to see that there aren't any other Merkle roots. And so there will be like. You'll probably be able to distinguish that the other person has like a backup script path. You won't know what necessarily it is, but you'll know that it's there. So there are some people that are like, well,
how risky is that from like a real true like threat model risk perspective? Like give me an example of when that would be like an issue.
So like if you were attempting to identify like a particular actor on chain, and they preferred using one sort of set of scripts, and you knew that they like never
like
just
they had
spent
a
with
pattern,
the key.
basically.
They had a pattern. You could sort of like remove those. Currently, the privacy benefit of this is pretty small because most people aren't using Taproot. And
it's like 2% of transactions or something crazy.
Yeah. And pay to script
2%
hash.
of value, not transactions.
Yeah.
It's like 2% of Bitcoin value is locked up in Taproot addresses right now. It's a very small amount of actual Bitcoin that's in Taproot addresses right now.
Right. Yeah.
Sorry.
And then pay to script hash, which is what a lot of people do for scripts, is you just reveal the whole script. So like it's more like a potential privacy gain that we could get at some point in the future. And I don't want to like write that off. But then the thing is, well, like if we do move everyone over to pay to Taproot in like 5 years or 7 years, and then a quantum computer shows up, we're like in even worse shape because pay to script hash isn't as vulnerable to quantum attacks, certain types of quantum attacks.
The ones that are the most low-hanging fruit. I mean, basically, right? Like any address that has a hashed public key in it, like it's going to be much more difficult for a quantum computer to take that Bitcoin than it would be if the public key is just like hanging out in the address, as in with Taproot addresses.
Right.
Okay. That's significant. So yeah, so you have to figure out what your threat model is. But basically, there is a minor privacy loss by removing key path spend and Taproot addresses potentially for some folks. But you get the benefit of quantum protection and just, removing public keys from the addresses in general. Any kind of threat to ECC could theoretically be problematic there.
Yeah. So I think that that's one major tension there, which is just like, how do if we move everyone to pay to Taproot, we take on this quantum risk, but we gain some privacy. And if we move everyone to BIP360, we mitigate the quantum risk to some degree for those people that moved over. But we now would not have the privacy benefit that we would have gotten from Taproot.
Okay, and so you kind of alluded to this basically. So like Taproot addresses right now are, because this public key is just exposed in the Taproot address itself, are susceptible to these kind of low-hanging fruit quantum attacks, long exposure attacks, which I've spoken about in depth with Hunter. I'll have to like post the link to our interview where we explain this. In order to prevent against short exposure attacks, which are more difficult to achieve, but ultimately we want to protect against those too, which means attacks of keys while they're waiting to be confirmed in the mempool, you need PQC.
That's 100% correct. Yeah.
Okay, you absolutely need PQC, or this sort of like weird Lamport signature opcat scheme.
Yeah. I mean, I would like, I know it's in there, and like I put it in opcat for completeness. But I think we would be in trouble if that was for the scheme we were using, just because retraining users to be like, oh, remember if you've ever used that pub key before, because if you ever, you wanted a fee bump, so you re-signed, oops.
Yeah, get your wallet hygiene handled right now.
Right.
Speaking of Taj, who's my next guest, have you looked at his lifeboat proposal at all? Do you have any thoughts about kind of alternative ways of navigating specifically these short exposure attacks in the mempool?
So this is the commit reveal?
Yeah, exactly. You basically like inscribe your TXID before you publish the transaction, and like a prior transaction is sort of like my take on that. Yeah.
I mean, I think it's a really cool protocol. I feel like if it becomes important, things have really gone wrong, and like either a quantum attack
is imminent.
Is imminent, and either we did nothing, which looks bad for Bitcoin, but maybe this protocol can help us survive, or someone invents a quantum computer tomorrow, completely blows up all the timelines, and we need something to survive.
Okay, so your team, let's actually get PQ signatures into Bitcoin to protect against these short exposure attacks at some point.
Yeah. Okay. I think we should have a plan that everyone kind of agrees that if quantum computers are real, this is what we should do. And then probably, given how we've seen things go in the past, we will gain sufficient warning so that everyone will be convinced that quantum computers are real, in time for us to make the change in a low risk, leisurely manner.
Okay, so final Jeopardy. What would it take, do you think, for people to really start thinking that quantum computers are real? Like, are there hints? What do we need to see in order for us to really feel like, okay, we need to get our acts together and implement these signatures or something similar?
I think if we started to see low strength, ECDSA or RSA keys that currently would not be considered secure being broken by quantum computers.
Smaller byte versions, right now we
right.
Yeah, okay.
So 1024-bit RSA, being broken, or, just smaller variants. There's some very small variants that have been broken, and there's some larger variants of RSA that are broken on classical computers. But even being able to do those, classical attacks on a quantum computer, for larger numbers.
Classical computers are still way more powerful than quantum computers, basically, is the bottom line.
Yeah. At most cryptanalytic tasks, there are a few. There's the random circuit sampling problem that people are building some really interesting authentication systems out of, that quantum computers are helpful for building security there.
Is there anyone in the quantum cryptography world that we should be following? Who are the people who are doing the most meaningful work on this, in your opinion?
I think the person that I like the most in the quantum cryptography world is Scott Aronson.
Okay.
He used to be an MIT professor. I think he's out in Texas. He has an excellent blog where he covers a lot of this stuff. And one of the reasons I actually started worrying about quantum computers was that I would read his blog, and he believes quantum computers are real and that they will have an effect on cryptography. But he was generally but no one needs to worry about that now. And then he's held this for like, 10 years, that they're really cool. He loves them. He's not a quantum skeptic, but like,
but it's far away.
It's not a practical concern at the moment.
Right.
And he's changed his mind somewhat, along with, other people in the field. But he's also just an excellent communicator. He taught this class at MIT, which he turned into a book that's, Quantum Computing Since Democritus, which is really, really good. As someone, I'm not like a quantum physicist, and I read the book, a while ago, and, both really enjoyed it and also thought he explained this stuff without needing a background in quantum physics.
Wow. Okay. That's a really good recommendation. Thank you so much. Anything else that you want people to know about BIP360 specifically?
BIP360 specifically. I do have one other thing I want to say, but, I think
please.
What I'll say about BIP360 specifically is that there's sort of two options to disabling the key path. Option one is pay to taproot and just disable the key path, and option two is BIP360. I think I prefer BIP360 because you can like opt into it. And so it may be the case that a quantum computer comes out and it's so threatening that we need to disable key path spends, and some people will lose money in taproot addresses where they haven't moved over to scripts. But if people have started using BIP360 prior to that point, those people will know they're sort of like protected. So I see them as basically like similar options, but one is like opt-in.
Makes sense to me. Yeah. Voluntary is generally considered, I mean, it's interesting, right? Because so Lop actually I had on the podcast recently too. And I think that this is sort of like, I think voluntary is going to be easier to like actually get pushed through, right? Like no one wants to be forced to do anything. At the same time, like you said, like there is this sort of broader conversation that we haven't gotten into, which is, if people don't comply, if people don't choose to opt in, do we have like a supply crisis, right? Like the Satoshi coins issue, right? Like if people don't fix the fact that they are dealing with reused addresses, should we force them for market purposes is a whole other conversation. I guess we could have it another later time. I went into much depth about this with Jameson Lop, so we'll spare the audience from that Satoshi coins conversation right now. Cool. Anything else that you said you had something else that you wanted to say?
So I used to always say like, if X happens, Bitcoin's doomed. And it's a very nice, like, intellectual shortcut where I'm like, I don't have to care about it. If ECDSA gets broken, Bitcoin's doomed. I don't have to care about it. I started, I said it a few months ago, and then I started to like feel bad about it. And I was like, why do I feel bad about this? And I came to this conclusion that like, I don't think that is the right way to view these problems. I think that shortcut is like a bad shortcut. The question is, what things would cause Bitcoin to be doomed, and how do we modify Bitcoin to mitigate those risks? Currently we're reliant on one signature scheme. But if we always had two very different signature schemes, then if one is broken, we'll always be able to like transition to the other one, especially if they're like in different tap leaves.
That just seems like a basic thing. Like, let's have like a couple different types of cryptography just in case.
Exactly. And like Bitcoin can survive. Like, I think if SHA-256 mining was broken, Bitcoin would survive. But I think the biggest threat to Bitcoin, is that if you could no longer authenticate the UTXO set,
right,
Bitcoin wouldn't really exist because you wouldn't know what the UTXO set,
the ledger would break.
Who owns it.
Yeah.
Right. So you would lose all the ownership. And I think that's really the core of
Bitcoin.
Bitcoin.
The most important part. Yeah.
So I've tried to turn the question around rather than like as a way of like, well, I'm not going to think about that because it's too catastrophic. It's like, I should think about that because it is catastrophic, and I should think about ways of making it less catastrophic.
Yeah, 100%. I'm with you. High five. Yeah. Thank you, Ethan.
Thanks.